bench tonight. We have a Samsung LN S4696D. And here's our symptom. Oh, might help if I turn on the power. Okay. Notice this. We have a blue light. And we have a relay clicking. So let's pop this unit apart and see what's causing the trouble. We begin by removing all of the screws from the back. Samsung are good in the fact that they do mark the screws with an arrow. So we start by removing the large screws that would be used to mount it on a wall mount. And then we remove all of the arrow marked screws around the edge of the cabinet. Here's something kind of cool I just noticed on this set. This particular set has IEEE 1394. In other words, firewire input. So now we've got the back off the TV, so we have basically 3 circuit boards that are under shield covers here. We have the main signal board, we have the timing controller board up here, and this is the power supply. Because the set's not starting, I'm going to go out on a limb and say we have a power supply problem. So the first thing we'll do is we'll remove the shielding from the power supply so that we can work on it. Maybe a capacitor problem. At this point I don't know where the problem is. It could be a bad backlight for that matter. This is not displaying the normal symptom. Normally when you have bad capacitors in the power supply on these Samsungs, the symptom is that they don't just sit there and pulse on and off like that. They normally just don't turn on at all, or they take longer and longer to turn on. The fact that this one is clicking, the relay is clicking, is a different symptom than what I normally see on these. So this could be an interesting fault. With the back removed, exposing the power supply on these Samsungs, usually the problem is these capacitors here. The ESR goes high and the tops get blown out on the top. And actually these caps here are bad. I can see that right from the get-go, that these ones down here, the tops are bulged. So it may just be that we have a bad capacitor problem on this unit and that there's no other fault. So these ones here are obviously bad because the tops of them are bulging, which is a very, very common problem on all these Samsung TVs that were of this vintage. Doesn't matter what model it is, they've all got problems with faulty capacitors in them. We're going to recap this board first before we go anywhere else. It may be that that is the only problem with this set, or we may have another problem on top of this, but let's get this board out first so that we can work on this on the bench. So once we've undone the plugs, remove the board, we're just going to remove the screws. They're marked with a marking, an arrow to mark all the screws. If you've got this television standing up on edge, obviously you're going to remove the screws from the bottom first and work your way up, because the last thing you need to have happen is the weight of the board swing down while you're unscrewing. If you undo the top screws first, the weight of the board is going to swing down and it could fracture the board. So you want to be careful when you remove the screws. Remove the bottom screws first, then hold the board as you remove the top one so that the board doesn't fall out. I mean, that's common sense, but hey, you'd be amazed at the number of times I see, people haven't done that and their board is fallen out and broken. We lift the board out like that. Now we can take this over to the bench and do some diagnostic testing on it. Just what the doctor ordered. Nice, good condition, 1000 high temperature, 1000 microfarad at 25 volt high temperature capacitors. Can be donated from 3 power supplies that were picked out of a garbage can at the local recycling facility. So I'm going to grab some parts off here and replace the components on this board. I'm going to change these ones. 1, 2, 3, 4, and 5. These ones are 1000 microfarad rated at 10 volts. And these ones are 1000 rated at 25. We'll test these ones, but I bet those ones are okay. These ones here are obviously bad though because of the raised tops. It says that's a no-brainer. I don't even need to test those ones. We know for sure that those ones are bad, and then we'll put the power supply back in and see if we have any other problems on this set. Now personally, I find the easiest way to get components out is just to heat them and wiggle. So just heat the pin up and just bend it slightly, heat both pins if you can, and just wiggle the component out. I don't bother with the expensive solder wicks. Sometimes you're at the advantage when you're dealing with the more modern solder, which is lead-free solder. If you just throw some of the good old high lead content solder on, it'll aid in removing components, because the lead-free solder takes a lot more heat to get it to flow. So if you can flow on some of the good old stuff, be liberal, and it generally makes the parts a little easier to remove. Just like that. Just heat them up and they'll literally just fall right out of the board. So there's two of them, and we'll do the same for the other ones. I'm going to use the same technique for removing the dead caps from the old board. Again, I'm just going to put some fresh solder on them, and that'll just allow them to come off the board that much easier. So there's one. Put some fresh solder on there and just give the cap a tilt and it'll come off. Same with the next one. We'll just throw some solder on there, give the cap a tilt, and it'll come off too. Same with this other one here. Again, and then we can go back after and clean up the board. Heat it up, pull the parts off. There's 3 of the dead ones out just like that. Those in the garbage, correction, recycle bin. Do the same for the other 2 that are showing their age right up here. That's these 2 here on the board. C852 and 853. They call them CM 852 and CM 853. Heat them up and they'll just drop off the board. Heat them up and they'll just drop off the board. There we go. Those 2 are off now as well. It's that quick. You can see, if we look at these things, you can see should be able to see the tops are kind of lifted on these ones, like the same with the other ones. So that's 5 caps off. We're going to get some solder wick out now, clean up the holes on here so we can remount the new ones, get this thing back together in no time. Let's get our solder wick on here and just pick up the excess solder. Now it's just a matter of soldering the new parts in. So we can flip the board back over and just start mounting our components. Negative is the side with the black mark on it. So negative, 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 and negative. Polarity is important. If you get it wrong, you'll have smoke. Quite simple as that. One, I'm just straightening the pins here with my pliers. Three. And 4. Turn the board up on its side. We don't turn it all the way over because the parts will fall out if we do that. And we'll just tack these in quickly just to hold them. Then I'll go back and resolder them in properly when I'm done here. So I'm just going to tack them in one side just for now, just to hold it in place so that they don't fall out while I'm There was one here that the hole wasn't quite clear, so we'll just clear that hole off and mount that cap. Now we can turn the board back over and do the final solder. Properly secure the components. Now we can go back and just scrape off this excess rosin that's around here from the solder wick. Make sure there's no shorts or anything. Some people will use chemicals on here. It's just as effective just to use a flat blade screwdriver and just scrape off, just ever so lightly rub it. The rosin that's sticking around will come off, and it'll also show you if you've got a connection that's bad. Like this one here doesn't look like it's soldered down properly, so we'll just reflow this one. Here we go. So now I've replaced the 5 obviously bad capacitors on the circuit board. I'm just going to get the ESR meter out. We're going to go measure some of the other ones and see what type of shape they're in. So a quick refresher course on what an ESR meter is. An ESR meter is a low ohms AC meter that tests capacitors in circuit using a low voltage. The voltage is less than 0.6 volts, so the voltage supplied through the probes will not turn on any solid state components. And that's the beauty of an ESR tester. ESR tester will test the equivalent series resistance of a capacitor. And if you remember from Capacitors 101, capacitors essentially just 2 metal plates, a piece of film that's wound up in a tight coil with a dielectric, typically paper saturated with oil, usually fish oil, between them. And that acts as an insulator. So it'll store a charge on these plates, a charge differential, a DC charge. But a capacitor with alternating current will readily pass it as the plate charges and discharges. So to test a capacitor with an ESR meter, the first thing we have to do is we have to remove any resistance of the leads itself. So we short the leads together and we press the 0 to zero it out. So now we've removed any resistance of the test leads. And now we can go down and we can actually measure the components on the circuit here. And this is 1000 microfarad, it's measuring 0.04. 1000 microfarad at 25 volts should be no worse than 0.08. So that one's 0.04, we're good. 0.04, we're good. Here's one of the ones that we just replaced, 0.02, 0.01, 0.04, and a couple more down here. 0.02, 0.01, 0.02. So it looks like we're good to go with our capacitors. If I got a range that was anywhere approaching 0.08, I would be removing them to test them further. Now sometimes there's capacitors in parallel, which they are in here. That can affect your reading. If you've got two caps in parallel, you'd expect your reading to be about half of what it would show for a new capacitor. These ones are in parallel. If I want an accurate reading of these ones, I would want to disconnect one lead of the cap or pull it completely and measure it. But I think we're probably okay. That one's not, there's nothing in parallel on that one. Actually, there's two of them in parallel here as well. But these ones, the tops aren't bulging on them. They are measuring well within spec. So I think we're probably okay, and it was just these 5, which are the usual ones that go bad. I don't know how many of these sets I've seen, but it seems like every one of these TVs that I see, this is the problem with it. It was a real big problem on these sets. So let's remount the board back in the television and we'll see if that's the only problem that the set has. Okay, we've put the board back in place. Now I'm just going to reconnect all the connectors that we've disconnected. Our 2 high voltage connectors for the fluorescent lamps, as this is a fluorescent backlit, so it uses the high voltage ballast down here for the, that's actually the lamp driver there. And now we just need to plug it in and see if it works. Moment of truth, we turn on the power. We have our blue flashing light. Sounds like the set's going to turn on. I don't have a signal input to this thing, so we're probably not going to see a signal until I hook one up, but we got a picture, component 2. So let's hook a source up to this and see if we actually, what type of picture we have off of it. So there it is. We're just pulling the signal off the air and it looks great. I don't know how many channels I get here. We'll just try changing the channel. And we get our local, yeah, the antenna is facing the wrong direction, so that station's not very strong. But that one will be good. And that one will be good. So, there we go. That's another one fixed. Another crappy Samsung with crappy power supply capacitors. Hope you enjoyed this video, and we'll see you in the next one.